This slide might be a little terrifying at first in terms of the network layers, but don't worry. The intent here is simply to show you that there's a lot of interpretations over the past few decades and a lot of propositions of how a network should be structured, how we should think about networks. We're going to focus on two primary models, the far left there and the far right. So we're going to look at a four-layer model, traditionally the TCP/IP model. And then on the far right, we will be looking at the OSI model, and we'll look at that model in more detail. But we just want you to understand that there are a lot of ways of thinking about this, a lot of different ways that a network can be implemented. And there are these layers that so you can logically think about, okay, what is the end application? And then all the way down to what is the actual physical medium of which all the bits are going to transfer over. So lots of different implementations of networks. So if you hear about layers, you might want to ask a little more detailed, what specific layer are they talking about? I think for most of our scientific users, fortunately, you won't have to get too low into the detail, but do understand that there's a lot of pieces and parts that go into this. So let's look at one specific model in particular. The open source interconnect model, or the OSI model, is a 7-layer model. And we will start, layer 1 is at the physical layer. Okay, and then we talk about protocol data units, or what's actually moving across that layer. And so physical layer, we're moving bits, the zeros and ones. To go one layer higher, we start moving bits between something, right? So we talk about this data link, and we have physical addressing, what we call MAC addressing, between two particular points. So from one machine to the other machine. In this context, a MAC address, this isn't a MAC in terms of an Apple laptop. MAC is a physical address of a network device. So the network card in my laptop will have a MAC address. My wireless card will have a MAC address. And if I had more than one network card, I could have multiple MAC addresses in a single machine. But this allows, through a particular switch, from one machine with a MAC address to another network card, the movement of data. And so that would be particularly considered a frame. More advanced data movement is in what we call the networking layer, where we would move a packet. And a packet takes that data frame and it puts a logical address to it. It gives it an IP address. And this is what we call routing. So now we have a network. We have multiple machines, maybe not all by the same owner. We have machines that we don't necessarily control. So we can route these packets from machines we control and say we'd like them to wind up somewhere else at another machine we don't control. And it can find its path through. So this logical routing layer, or IP addressing, allows for much more advanced data movement than would be allowed with just a data link, where we had to actually know the physical address of one particular machine that was part of its network card to another machine. Beyond the networking layer, we get to layer 4, the transport layer. And now we start thinking about protocols. So if we can get from one point to the other, how are we going to move those packets? And so we start moving them as segments. And TCP is probably the most popular, most widely used transport layer. There's also UDP, and they can have different capabilities to do congestion control. So we've got lots of packets coming in from lots of different people landing at the same machine or going through particular switches. We can have a little more congestion control as we do that with this particular transport protocol. The next 3 layers are often wrapped up, at least in part, into kind of your end target, such that you establish a connection at that end target. You may have moved the data over encrypted. You may have moved it over in a way such that you wanted to do compression. So any of these particular, we call that the presentation layer, encoding for security or for performance reasons, and then the end application. At the end of the day, we've moved all this data around. We want to do something with the data. So are we going to process that with HTTP in a browser? Are we going to catch the data as a file with secure copy or FTP? We have to actually have that data land somewhere and be understood by an application, whether that be file or some other sort of application.